So number 19, we'll go ahead and go through. It is solving this for like a least possible value. So first of all, again, when you see if and a comma, you should always try to solve for the pieces that exist between those. So we have 3p minus 2 is less or greater than or equal to 1. Anyone, what do I do? Add a 2. So we're going to add 2 to both sides. And then anyone? Divide by 3. So that cancels 2. P is greater than or equal to 1. So if I'm looking at it like a number line, here's 0, here's 1. Because this is equal, it's going to be a closed dot. And because it says greater than, we are going to shade everything to the right. So now, just for this small equation, my solutions include 1, 2, 1.3, 8, anything that is 1 or bigger as far as going to the right.
Positive infinity.
Hold up, no, I'm not asking for questions, so please don't respond, okay? So 1, 2, 3, so on and so forth going forward, that's the p's that are going to be eligible for this 3p plus 2, okay? So if I plug in, so here's 3p plus 2, and here's p. If I plug in 1, 2, 3, 4, 5, so on and so forth, I could just keep going on forever. So as I plug them in, if I plug in 1, I will get 3 plus 2 is 5. If I plug in 2, I will get 3 times 2 plus 2 will be 8, and so on and so forth. Okay? So the least one that's possible in this sense is going to be 5. They're trying to trick you because right now they're asking you what's the least possible value. And here you see that 1 is a lot lower than 5, and that's the outlier. People will choose 1 because they need to just read just a little bit more and see what we're actually looking for. Any questions? Okay, what's the next number that was the most missed that we can work on? Okay, so like I said, we are not going to do ones that require a little bit more reading. You know what I mean? As far as the homework that you guys get assigned, there's a time and a place for these questions. That's why I skipped 22. But going to 28, you'll definitely see a lot of this practice on tonight's homework all the way to Sunday. And it's dealing with something called quadratics. Yeah. So the parabola on this, what this question is asking is, it says, which of the following is an equivalent form function f above in which the minimum value f appears as a constant or a coefficient? Okay. So looking at this, if I were to graph it, this is how we do this. First thing that I want to teach you is that anything in parentheses, for all extensive purposes, I want you to interpret the opposite. So when I see something in parentheses like this, a lot of times, especially with this context, we set equal to 0. And if I asked you to solve for x, you would just subtract 6 to the right side, and you see that the answer is negative 6. That means this value is negative 6. That would make this binomial equal to 0. Okay? So with that, if I just look at this and say, everything in parentheses I interpret the opposite, then this is going to be an interpretation of negative 6. And this is an interpretation of a positive 4. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. Secondly, the fact that this is a positive x squared, okay, shows that this will smile up. So parabolas will either smile up or they will frown down, if you will. Okay? So a positive will smile up, but a negative, in other words, if there's a negative coefficient right here, it will smile down. So I can look at this graph and go ahead and graph the following. Something that looks like this. Okay? So if I'm looking at the minimum value will occur right here in the middle. And if you don't already know this, some of you are learning this actually right now or reviewing it. This is called the vertex. Okay? And the vertex will always occur halfway between the two x-intercepts. So halfway, wherever that is halfway, that's where the vertex is going to occur. Okay? So if I want to know halfway between two x values, all I need to do is add those x values and divide by 2. Just like if I were to ask you, what's halfway if you have an 80 on a test and a 100 on test, you would say a 90. Your average is a halfway point. So the halfway between this would be -6 plus 4 is a -2. Divided by 2, your halfway is at -1. Okay? So you already know wherever it is, it's going to be at -1. So which of the following is an equivalent form of what's happening here? See, and the reason why I'm showing you this -1 is that this is my halfway point, and this is an axis of symmetry. These two, one of them is already kind of screaming at you an x value of -1. Which one is it? The answer is D, because parentheses, we interpret the opposite. So for sure, this
They're
right
like
here,
jail cells.
say again?
They're like jail cells. If you
Yeah,
if
yeah,
you
that's a
take
good analogy.
away it,
Yeah.
it's like if you minusing it, you're taking away from that if you're
We got it.
putting more
But
back.
so in parentheses, whatever it is, it's going to be interpreted as the opposite. Okay. I only want to get through a lot of questions. Okay. So as soon as we know it, I just want to keep moving on. Okay. So this -1 is going to be here. It is interpreting the opposite, and D would be the answer. Now, this one is an equivalent form, but what if I asked you, what is the minimum value? The minimum value is whatever this y value is the answer. So a little bit of review for some of you, a little bit of practice kind of with knowledge that you've been recently doing with absolute value functions in your class. What would be the minimum value if this is the equation? Go ahead and guess from what you read. -25. Perfect. Because this right here, the parent function, and again, you're going to learn a lot of this as far as in the homework that I'm assigning tonight, and that's due on Sunday, both from Delta Math and from the book. This is the default parent function. This is where we start. This is default. There are no extra skins, there are no extra weapons, or whatever analogy you want to use with video games or whatnot. This is the bare bones, okay? And when I start changing this, right here, what I've done is just shifted it 1 to the left, okay? So my bare bones, x squared, has now shifted 1 to the left to become this, okay? And this right here says that I'm not going to shift left to right, I'm going to shift up and down. What direction? Down. Okay, so it'll go all the way down to a 25, a -25, and the graph looks like this. So the moral of this problem is that anything in parentheses, I want you to interpret the opposite. Anything outside of the parentheses, you follow the rule. You with me? So outside of the parentheses, it's up and down. Inside the parentheses is left and right. If it's inside parentheses, just like the analogy of the jail cell, that's a good analogy, you do the opposite. But if it's on the outside, you follow the rule. If it's at +25, we'd go up. But it's at -25, we go down. Are we good? Okay, so I did do a little bit of extension other than just answering that question. All right, what's another one that we could go over from the data? This is one that we are definitely ready for right now and very commonly missed. So in the study of bat migration habits, 240 male bats and 160 female bats have been tagged. If 100 more female bats are tagged, so plus one more 100, how many more bats must be tagged? How many male bats must be tagged so that 3/5 of the total number of bats in the study are male? So we want 3/5 of the total to equal male. Okay? So right now, if I'm looking for males, and 3/5 of the total equals male, what I'm trying to find is, what are the males over the total? You understand? So the male over the total will be just male over male plus female. Do y'all see what I'm doing? And this is going to be 3/5. The biggest thing that we're getting right now is this setup, oops, this setup equal to this right here. Okay, so as of right now for the male part, I have 240. And the male I have 240. And the female I have 160. But I'm also going to what? Add 100 for the female. So this is all my females right now. You with me? So if I'm doing 240, which is my current male, do you see how I have to actually add like X to the top? And I also have to add like X to the bottom. Do you see how everything works now?
Yeah.
I now have a total for my total.
Yeah.
I have a total for males, and it all is going to equal, you tell me, 3/5. So if you don't know this already, all right, so using the Inspire, which is allowed on the SAT and PSAT, okay? The Inspire is, it just is not allowed on the ACT, okay? The model that I'm talking about is the TI Inspire CXCAS. This is good for PSAT and SAT, but it's not good for the ACT. The only one that they allow on the ACT is the one that's called the TI Inspire just CX. The difference is this CAS. That one doesn't have it. Just FYI, if you are needing, which you will need to for admissions and scholarships for college, this is a good calculator to use. And the layout, the buttons, and everything are the same on both of these models. So you could just get used to this model right here that I'm showing you, and then on the ACT, borrow one of these CX from a friend or something, and just use the same layout, okay? Well, let me show you this. This problem right here can be a little bit hefty. Doing it by hand would require you to add these, add this, so that you get like 260 plus 240 is 500 plus X, and then it'd be like 240 plus X is equal to 3/5. Then you'd cross multiply, you divide, you do all kinds of stuff, right? Especially if you did it with the calculator, you could save a little bit of time, but you're still doing a lot of work. With this calculator, the Inspire, which is again allowed, you can bypass a lot of these steps by telling the calculator to solve it for you. Solve all of this for X. And it'll spit out the answer just like that. Okay? Here we go. Follow me so that we know how to use the calculator and how to actually input this into the calculator. So I've taken a picture so you can follow along with me as I use my calculator right here. Alright, so we'll go to so let me capture my calculator that I signed in with just now, and here we go. Follow me. We're going to press menu, 3 for algebra, 1 for solve. And then we're going to do control, this blue button right here, divide. We're going to do 3/5.
Hold on, you usually go a little bit slower.
Okay.
Menu, where's that? Menu.
Okay, so 3/5 is equal to the following. So the equals button, a lot of people mistaken that for the enter button. The equals button is right here underneath control. Okay, so look for the blue button, and right underneath the blue button is the equal sign. Now do control divide to get a nice pretty fraction going again. And now we're going to put 240 plus X. Guys, the X is way down here on the bottom, okay? X, Y, Z are commonly used. Okay? Now I'm going to go for my total. So I will press down arrow, And now, just like we set it up, I'm going to put parentheses 240 plus x, and then I'm going to do plus parentheses 160 plus 100. Now press this arrow button to the right so that you can kick out to the very, very far right. And now we're going to tell it what to solve for. What variable do we want it to solve for? X. So we're going to do comma x. If we put t, if we put z, whatever variable we set it equal to, that's what we're going to put here. So we'll do comma x, and then just press enter. And it'll give you your answer just like that. It does all of those intermittent steps for you, but it's a calculator problem, so this is allowed. So people who know how to effectively use this calculator can save a lot of time, okay? Any questions? The hardest part was just setting it up, but you saw how we went through it to set that up. Okay. So this calculator, let me go back over here. This calculator is called the TI Nspire CX-CAS. And right now, guys, this right here, this model is probably obsolete to where right now they're selling the second model version. Okay, so these are, I don't think they sell these anymore. I think that even they have a picture like this on Amazon, they will send you the blue one. So it's got like blue trim, and it's the second model. Okay? Does everything that this one does. It's a little nicer. And a little cheaper. Okay? Questions on this one? Okay, so let me pause this. Okay, so 36 is also a common struggle people have. And it's just from remembering. It's been a while since we've done geometry, some of us. And this is very, very important. Not drawn to scale. So don't assume whenever it says not drawn to scale, if I have something like this and there's a line here, don't assume that this is cutting it perfectly in half to give 45 degrees, okay? That's what this statement means right here. It means that you have to use geometry knowledge to verify the pieces that are shown, okay? So here we go. In the figure above, the circle has a center O and has a radius of 10. So already, I will go over here and put the radius is 10. If the length of the arc AB, shown in bold, so right here, this is AB, is between 5 and 6, what is the possible integer value of x? So this is like between 5 and 6. That's how long this arc is right here. Okay, and it can be 5 inches, 6 inches, it doesn't matter, it's 5 and 6, or 5 feet. What is a possible integer value? So we want a whole number, no decimal, for x. If you were to guess x right now, just guess it, about how many degrees does that look like? 45? Okay, somewhere close to 45. And if it's not 45, what else could you guess? Just off your intuition and best guess.
60 and 90.
60 and 90?
60, 30.
Okay, so you're thinking 60, 40. So here's the thing, is that when you get to these problems, especially the way it's set in integer, if you run out of time, just guess something. You know what I mean? You might get lucky, and there's points for that score that you could get. All right, so let's go ahead and now figure it out of what it is. So if it's 5 and the radius is 10, right now what you can do is you can create this like 2 different case scenarios. You can create it if it's 5, and you can create it if it's 6. Okay? And the equation that we're going to be working with on this is going to be the following. So the circumference is 2 pi r. Okay, you with me? So let's say that the radius is 10, and if the radius is 10, then I know that this circumference is 20 pi. And this circumference over here would be what? It's still 20 pi, right? So 20 pi. So if I'm looking at this, these right here are the whole thing. It's not just a piece, but it's the whole thing. You with me? So if I have this going on, what I want you to think of is like a piece, just drawing a pizza slice, over the whole. So a piece over the whole. So if the whole circumference here is 20 pi, because we had, again, 2 pi r, and now I'm saying that this piece is 5, I'm saying it could be 5 out of 20 pi. You with me? Like a piece over the whole. And this one is saying like 6. It's like a fraction. 6 out of 20 pi. Okay? So what I want to do now is I want to go to the calculator, and we're going to figure out what does this look like as far as degrees. Okay? So here we go. Let's go to the calculator first. So I have control divide 5 over 20. And guys, in the denominator, I'm going to put pi by accessing this key down here at the very bottom left. It's near that comma. It's not highlighting red. I don't know why. There it goes. We're going to press pi, and then we're going to get this first one right there. And when I press control enter, this is what I get. Okay? So if I want, this is a radian measure by, first of all, that you need to know. This is a radian. This isn't an angle. And if I want to change this to an angle, I'm going to multiply by this right here. When I get a number like that, and I want to change a radian into a degrees, I'm going to take my answer and I'm going to multiply it by 180 over pi. Okay? This is knowledge base. If I wanted to take a degree and change it to radian, I would take my answer and I would multiply it by what? What do you think? It'll be the reciprocal of this. It would be pi over 180. Okay? So I got this right here, right now. I need to multiply by 180 over pi in order to get my answer. Okay? So let's go ahead and come over here to our answer that we got for our first one. And we're going to multiply this. So just press multiply. Or if you want to go up there and grab it, you can just press enter. And we're going to multiply by control divide 180 over pi. And I get this right here. You with me? And then the other one I could do is, let's see, the other one was, where is it at? 6. So if I go over here and I do 6, it'll be 6 is a part of 20 over pi. And, whoops, let me press control enter to get a decimal. This I will multiply by 180 over pi, and I get this. So basically, you could, there's 4 and there's 5, you could put either one. You see what I'm saying? So you could, what number would be existing between 4.5 and 5.4? That's an integer.
That would be 5.
Just 5. Yeah, so you could just put 5. Now I know that does not look anywhere near 5, but that's how you would do this in this respect. Okay? Do y'all see how I did that? The piece over the whole, and I got it as a fraction. Hold up, I think I made an error because you're not looking convinced that this is 5. You're thinking that it's more, and I did do an error. So let's fix this real quick. first one is 5 over 20 over pi. Do you agree? Okay. And if it doesn't, hey, if it doesn't make sense in your mind, don't just nod yes. Just ask, what? No, that doesn't make sense. So 5 over 20 pi is the fraction of the entire circle. Do you agree? Okay. How many degrees is the entire circle? 360. So I will multiply this by 360. There we go. That looks much, much better. So we have 28.6. You with me? So the other one, do you see how I'm just going up and pressing enter to bring it down? I'm going to multiply this one by what? By 360. So there you go. 28.6 all the way to 34.4. Any integer in between those two numbers would work for x. You understand? So I was doing something different, just disregard that, no worries. But we're recording, at least we did fix it. Okay? Questions? Okay, so let me pause this. Thank you for stopping me. And let's do a couple more.